electricity, right? So take the name of devil, and devil is here. Hi, Dasika. How are you?
I'm good, thank you. How are you?
I'm doing fine. Let's get started. You are joining only 2 classes. Do you know, Dasika?
3.
Is that enough for you? Okay. Similarly, Jasmita sometimes join the weekday classes. I can assure you they are not at par, but they are good enough. Anyway, electricity. So what we have right now is here, let us say plus minus, and there is some resistance. We discussed about force is equal to 1 by 4 pi epsilon naught q1 q2 by r square, right?
Yes, sir.
And field E being field, and field was df by dq. So field was 1 by 4 pi epsilon naught q by r square, and f equal to qe. Any question? Are we clear?
Yes, sir. Yes, sir.
The work was F into S, and that was, I cannot tell you people how, but 1 by 4 pi epsilon naught Q1 Q2 by R, and work will be from infinity to R. Any question? And the volt was again, V equal to potential, and potential is defined as dW by dQ, or also W equal to QV. And this was 1 by 4 pi epsilon naught Q by R. So these were a few things. So we need to understand a few things, which is easier to understand. 1 by 4 pi epsilon naught Q by R square, and potential is 1 by 4 pi epsilon naught Q by R. Force is equal to Q and E, and work equal to Q and V. Okay, we'll talk more of this. I'm not going back. So what if I have a battery and I have a battery which is like this. This is plus, this is minus. So current flows like this. Any question?
No.
Current is flowing like this. This R is called some resistance. R equal to current. R equal to resistance. Everything which stops current from flowing is resistance. And you know this V is volt, right?
Yeah.
Yes.
And more the volt, more the current. Yes or no?
Yes, sir.
Yeah.
So now, more the resistance, what will happen? This is V equal to IR, where R is
Constant.
resistance. Any question?
No, sir.
Any question?
No, sir.
So we got few things very clear. F equal to QE, W equal to QV, and V equal to IR. Are we clear?
Yes, sir.
Good. Now the question is, what happens when we connect multiple things? Okay. So most of questions come at your level, which is what happens if I connect 2 currents, right? Sorry, 2 resistances. Yes or no? So you see, I is current flowing. So obviously the same current will keep on flowing. I, yes or no? Because electron is flowing, electron is not stopping anywhere, so it will be I. Anybody has any question?
No.
And this is, suppose this is A, and this is B, and this is 10 volt. Do you understand?
Yeah.
Any question?
No, sir.
So voltage of AB equal to voltage of B minus voltage of A equal to 10 volt. Any question anybody has?
No.
Right? Any question anybody has?
No, sir.
Which voltage is more, B or A? So the problem is that name is wrong. I will do it from A to B. Current is flowing from A to B. Do you understand?
Yes, sir.
Yes.
So let me redraw and see whether you understand or not. This is a battery. I deliberately do like this. and this is current plus and minus, right? And I have a resistance here, two resistances. Any question?
No.
See, this is point A and this is point B, right?
Yeah.
This is point C and this is point D, this is point E. Current is flowing from B to A. Sorry, I will change the numbers because current starts flowing from here. So A, B, any question?
No, sir.
C, current is flowing like this, then D, and then E. Any question?
No, sir.
Are we clear?
Yeah.
Yes or no?
Yes.
So current is flowing from I from A to E. Yes or no?
Yes, sir.
Current is flowing from A to E. Why? Why? Due to voltage difference VAE. Any question?
No, sir. No, sir.
Any question? Yes or no? What will be voltage from E to E? VE minus VE equal to 0, right?
Yes, sir. Yes, sir.
VAB equal to how much?
PB minus VA.
Why 0? There is no battery. There is no source of voltage. Source or consumer of voltage. Do you see or not? Between A and B, neither there is battery nor any bulb, heater or something which is resistance. Are we clear?
Yes, sir.
Yes or no?
Yes, sir.
If this is 10 volt, VAB equal to how much? Sorry,
BB minus
AE equal to how much? 10 volt, right?
Yes,
Yes or no?
Yes, sir.
In fact, the thing is, we will have this is plus 10, this is plus 10 volt, and this is 0 volt. Any question?
No, sir.
If this is plus 40, this is plus 30. Are you getting it? If this is minus 20 volt, this is minus 30 volt. Are you getting or not?
Yes, sir. Yes, sir.
We don't bother how much is the absolute value. The potential difference between A and B is what? 10 volt. Are we clear?
Yes, sir.
Yes or no?
Yes, sir.
So to keep things simple, I'll say this is plus 10 volt and this is 0 volt. Any question?
No.
I could have said plus 15 volt and
Plus 5.
plus 5 volts. I could have told plus 5 volt and minus 5 volt. Are we clear or not?
Yes, sir.
Yes.
Now look at. So let us start calculating again the same picture. Let us say all of you are going to draw this picture. Please draw this picture. And at A, was any voltage consumed?
No, sir.
So this is still plus 10 volt. At B, was voltage consumed?
No, sir.
No.
So this is still plus 10 volt, right?
Yeah.
At C, voltage was consumed.
Yes, sir.
Yes.
So let us assume that it was consumed. So let us say 7 volt. Assume, right?
No.
Yes or no?
Yeah.
Yes, sir.
After this, what will happen? Between C and D, voltage was consumed.
Yes.
Yes, sir.
So let us say it consumed and now it is 3 volt left, right?
Yeah.
So what happens now? This will also be 3 volt
Yes, sir.
and this will be also 3 volt. We made a mistake. What should have happened? If this was 0 volt, this will be 0 volt. Yes or no? So we cannot assume this. This has to be 0 volt. Any question?
No.
Yes or no?
No, sir.
Are we clear or not?
Yes, sir.
Yes?
Yeah.
Hey, Rishi.
Hello.
Are we clear?
Yes.
Yes or no?
Yes, sir.
So now let us understand. If I have a battery here and if I'm connected to 3 resistances, okay? 10 seconds. Press button. Now you see, this is 0 volt and this is V. Any question?
No.
This is 0 and this is V. Any question?
No, sir.
If this consumes V1, right? This one will be V, yes or no? And this one will be V minus V1. If this consumes V2, V minus V1 minus V2. If this consumes V3, V1 minus V2, sorry, V minus V1 minus V2 minus V3. And from this side, that should be equal to 0. Any question?
No.
Are we clear? Anybody has any question regarding this?
No, sir.
Are you sure?
Yes, sir.
Anybody has any question?
No.
Good. Let us understand what if we do this one in parallel. So I connect this to this. I connect this to this, right? This one is V, this one is 0, right? Yes or no?
Yes, sir.
Look at this circuit. How much will be this?
V.
If this is V1, this will be V minus V1 equal to 0?
Yes, sir.
Yes or no?
Yes, sir.
Yes.
Yes or no?
Yes.
If I take this circuit, this will be V. And if this is V2, this will be V minus V2 equal to 0? Yes or no?
Yes, sir.
You people understand this or not?
Yes, sir.
Are we clear?
Yeah.
Are you sure?
Yeah.
Right? In this case, everywhere current flowing is I. I. Same current is flowing here, I. Same current is flowing here, I. Same current is flowing here, I. Any question?
No.
No, sir.
In this case, if current this is flowing I, this is divided into I1 and I minus I1. Any question?
No.
No, sir.
Are we clear or any doubt we have?
Yes, sir. Yes, sir.
Here I minus I1 comes back and this I1 comes back and this again becomes I. Are we clear?
Yes.
So at any joint in a circuit, if currents flowing like this, I1, I2, I3, I4, I5, what equation you can write? What equation you can write?
Add everything.
I1 plus I2 minus I3 minus I4 minus I5 equal to 0. Okay? This is called, can you people find out what is this name called? Please go to Google and find out so that I will correct myself also. In school, we used to read Kirchhoff law.
The current flowing into a node must be equal to the current flowing out of it.
No. Pronunciation here.
Yes, sir.
Wow, do you read that?
Yeah. There's off. Okay.
Read loud. Read loud for me.
Kirchhoff. Kirchhoff.
There's off.
Kirchhoff.
Pardon? Read out loud.
Kirchhoff.
I told you to search in Google, not to guess. I know how to guess. Right.
Kirchhoff.
Kirchhoff.
Kirchhoff is wrong one. He's a German guy. Check German pronunciation. No?
Sir, Kirchhoff. That's what they told in the video.
Okay.
Sir,
Kirchhoff.
the German pronunciation is Kirchhoff.
Kirchhoff. Kirchhoff. Something. Kirchhoff.
Something like that.
Yes. Kirchhoff.
So people say Kirchhoff, Kirchhoff, and so on. The German pronunciation is Kirchhoff.
Yeah, that's what we said.
Kirchhoff. So check with your teacher what he says.
Yeah, that's what we said.
I didn't hear you, dear. I told you to speak again louder. Can you pull your screen down a bit? Yeah, good. Speak louder. Because when you speak in lower tone, even if you say right, nobody notices you. The difference between a leader and a follower is just very basic. A leader shouts and everybody hears. A follower might be more knowledgeable, but he doesn't speak. That's the only difference. Leader is not a smarter. Leader makes himself heard. Okay. Are we clear? Kirchhoff law or Kirchhoff law or Kirchhoff law? Right?
Yeah.
Kirchhoff is certainly wrong. which I'm used to saying. Most of the times you will see me saying Kirchhoff because I have read that in school, college. Every professor of mine used to say Kirchhoff. Now I know that is wrong. Kirchhoff is not correct. Are we clear about this? Or anybody needs any further explanation?
No.
Kirchhoff law says that if there is no source of voltage or no sink of voltage, that means no battery or no equipment which consumes electricity, the sum of currents at that point will be 0. Are we clear? You have to take incoming as plus and outgoing as minus, or incoming as minus, outgoing as plus, right? The sum of all currents, taking direction into consideration, is 0. Whichever way you like to write Kirchhoff or Kirchhoff laws are, law has been interpreted and textualized in different ways. The summary is that if there is no sink or source at a point in a circuit, the sum of incoming and outgoing currents is 0, right? Or sum of incoming currents is equal to sum of outgoing. Are we clear? Any doubt we have?
No.
Right? So now let us come back and find out if I have a voltage, this is V, and I have 2 resistances connected in series, right? As you see, right? Yes or no? This is R1, this is R2, and current flowing is I. Any question?
No.
So suppose we had a circuit which had single resistance in place of R1 and R2. So this was V, this was I, and this was what? I. Any question? As you see, V equal to IR. Any question?
Yes.
And now we know if this is V1, this is V2, this is 0. Any question? So voltage at this point is V, at this point is V minus V1. At this point is V minus V1 minus V2 equal to 0. Any question? So if we write V minus V1 minus V2 equal to 0, right?
Yes.
Yes or no?
Yes, sir.
From right side, V equal to?
IR.
Oh, let us first simplify this. Any question? V equal to what? IR? V1 equal to? V1 equal to IR1 because same current is flowing, and V2 equal to IR2. Any question?
No, sir.
So IR1 plus IR2, what can we cancel?
I.
R equal to R1 plus R2. That's it. Are we clear?
Yes.
The resistances connected in a series. R equal to R1 plus R2 plus R3 plus and so on. Any question?
No, sir.
Any question?
No, sir.
No, sir.
Do you understand this or not? First diagram.
Yes,
Yeah.
sir.
Second diagram is just equivalent of that. Do you understand this one, how I wrote or not?
Yeah.
Yes, sir.
Yes or no?
Yes.
In whole circuit, voltage is consumed by V1 and V2. That's it. Yes or no? Now let us understand what if it is parallel. So I have this circuit and 2 resistances are connected like this. Right? Yes or no?
Yeah.
Yes, sir.
If this current is I1 and this current is I2, right? Obviously, this current is I2, this current is I1, and this current is I. Any question? This is V, this is 0. Any question? If we have equivalent circuit with single resistance, this will be like this. Any question? Any question?
No, sir.
No, sir.
No.
Right side, we are replacing 2 resistances with single one. Right? At this point, what we can write?
V is equal to IR.
Now, I equal to I1 plus I2. Yes or no?
Yes, sir.
And formula is V equal to IR. So I equal to V by R. Any question?
No, sir.
I1 equal to V1 by?
R.
But same voltage is there. You see here, this is V, this is 0. Yes or no? This is V, this is 0. Any question?
No.
Any question or you people have?
No, sir.
No, sir.
No.
And I2 equal to what? Again, V by R. R1, R2. Any question?
No, sir.
You people understand or not?
Yes, sir.
Understood that same voltage is there or not?
Understood, sir.
So what will happen? V by R equal to V by R1 plus V by R2. Any question?
No, sir.
What can we do?
We can take V common and cancel.
Right? So in a parallel, okay, in parallel, the resultant resistance is 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on. Any question?
No, sir.
No, sir.
Any question? So we got 2 things. Now the question is, what if I connect to a battery. This is plus, this is minus. And I connect to this. This is 27 ohm resistance. This is also 27 ohm resistance. And this is 9 ohm resistance. Okay? And this is 5 ohm resistance, and this is 10 ohm resistance. Voltage is 20 volt. What is current flowing? I equal to what? And so, what is I1? What is I2? And what is I3? Did you understand?
Yes, sir.
So how we are going to solve it? Any idea?
So the parallel connection, we can first solve that.
Look, this is no different than any other question in any other branch. We have to, listen here, we have to convert whole this thing into a single resistance. Any question?
No, sir.